these equations all have 3 terms. So we're not going to be able to use the square root method. We could use completing the square. I can tell that these will not factor. So we can use completing the square, the quadratic formula. I tend to use the quadratic formula. So here a is 1, b is -3, c is 5. So x equals negative of -3, so 3, plus or minus the square root of b squared, -3 squared is 9, minus 4 times a times c. So 4 times 1 times 5 will be 5, all over 2a, in this case will be a 2. So x equals 3 plus or minus the square root. 9 minus 20. Ooh, that's -11, all over 2. Now, the -11, we never leave a square root of a negative. So we pull out the I and leave it the square root of 11. There are no perfect squares in 11, so then we're done. X equals 3 plus or minus I times the square root of 11 over 2. Let's try this one more. We need to get it equal to 0. 3x squared plus 4x, this will become plus 3 equals 0. A is 3, b is 4, c is 3. So x equals -b, so -4 plus or minus the square root of b squared is 16 minus 4 times a times c. Well, 3 times 3 is 9, all over 2a. 2 times 3 is 6. X equals -4 plus or minus the square root. 4 times 6 is 36. 16 minus 36 is -20, all over 6. -20, so that's a -1 times 4 times 5. And x equals -4 plus or minus. Square root of 4 is 2. Square root of -1 is I. And then we leave the square root of 5 all over 6. You might notice these are all even numbers, 4, 2, and 6. Since they're all even numbers, I can divide them each by 2. And x turns out in simplified form to be -2 plus or minus I times the square root of 5 all over 3. And that becomes my solution.